Hello, this lesson is section 9.8, special segments in a circle. Let's get started. Okay, so if you do have your book, a few people do still have their book, but this is actually a section that's not going to be corresponding with the book. So this is from an old advanced geometry book that the high school has used. So this is strictly on special segments in a circle. All right, so with this section, it's fairly quick. So I'm going to go pretty fast to the first few pages today, try to get this video down in time. But let's start with the first section on Theorem 10.15. So a couple notes here. When two chords in a circle intersect, four smaller segments are defined. You may recall in lesson 9.6, you learned how to find lengths of parts of a chord that is intersected by the perpendicular diameter. Today we're going to learn how to find lengths for other intersecting chords. So this brings us to the segment of chords theorem. What this states that if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. Okay, so you have your circle here and your two chords that are intersecting. So you have AB times BC is equal to DB times BE. So here's some notes for you. So let's call this little a right here, okay? Little a, let's call this little b, this segment here, okay? Let's call this little c. And let's call this little d. Okay, so little a, little b, little c, little d. So basically what this theorem states is that if you take A times B, A times B, that's going to equal C times D. Or in other words, intersecting chords rule states this: segment piece times the segment piece. So little a times little b is equal to the segment piece times the segment piece. Let's start with example 1 here. So these are fun to do. So you're given a 4, you're given a 6, and given a 3 in a circle here. And you're going to be using the theorem recently mentioned to solve for x. Okay? So let's go 6 times x. 6 times x is equal to 4 times 3. 4 times 3, which is equal to 12. Divide by 6 on both sides of the equation, you get x is equal to 2. Not too tough. Let's move on to b. 12, 9, 8, and x. Okay, so you've got 8 times x is equal to 12 times 9. 12 times 9 is 108. Okay, 12 times 9 is 108. All right, so now we're going to divide by 8 on both sides of the equation, and you're going to have x is equal to 13.5. 13.5. And that is page 1. Okay, let's move on. Not too tough. Here's letter C. You've got yourself a diameter, radius I should say, of 10. And you get this little segment here is 2. And so that tells me that this segment right here is going to be 8. Okay. 2 plus 8 is 10. And you've got an x on this side and an x on this side. So we're going to take 2 and multiply by 18. And that will equal x times x. So x times x is x squared. 2 times 18 is 36. Now we're going to undo the squaring of this x by taking the square root of it. X is 6. Not too tough. Let's move on. Letter D. You have 3, 6, x plus 7, and x. All right, so let's take 3 times 6 first. That will equal x times x plus 7. Now we're going to move into distributive property. This is 18. X squared plus 7x. All right, now we're going to solve for x. Subtract 18 from both sides. You would have x squared plus 7x minus 18 is equal to 0. Now solve for x by factoring. Okay, so factor. You have a negative 18. So we're using the T method here. What two numbers gets you negative 18? That when you add them together, you get 7. Okay, and I'm sure you realize right away that that will be positive 9 times a negative 2 would get you positive 7. Okay, that's going to tell you that x is either x plus 9 is equal to 0, x is negative 9, or x minus 2 is equal to 0, x minus 2 equals 0. And that would mean that x is equal to 2. All right, now when you're factoring, sometimes you get these two answers here. And you got to look at the problem. And the problem, if it relates to the problem of a negative 9, that would be of a negative distance. So we're just going to cross this negative 9 off. It doesn't make sense in the problem. We're going to work with this answer, x is 2. So if you look at x is 2, the negative 9, this is a positive distance. So 2 plus 7 is 9, and x is 2, equals to 2. And that is letter D. Moving on, you have a diameter x plus 2. You have a 5, okay? So that would mean that x plus 2 times x plus 2 is equal to 5. This is not even a theorem. You could just say that. X is 3. Letter F. You have yourself x, and you've got a 90-degree angle there, so you know that this is x from our previous theorems. You have this radius as 7, and this little segment is 2. So that tells me that this is going to be 5. All right. So we're going to move ahead here. We're going to take this x times this x. And that will equal this little 2 times 12. 5 and 7. So that puts you at x squared is equal to 24. And the undoing of the squaring with the square root, you get the square root of 24 is equal to x. Okay, so now you know that the square root of 24 can be expressed as 4 times 6. The square root of 4 is 2. So let's simplify that radical out. 2 square root of 6, or 4.9. All right, page 3. So this is the review on trinomial factoring rules. Okay, so just keep this in mind. This is your pattern. So if you have this from last year when you had factoring, this will help guide you. So if you have a plus and a plus, your product will be plus and plus. You have a minus plus, you'd have minus minus. Plus minus, you'd have a plus minus. And minus minus, you'd have plus minus. All right, next theorem. Gets a little tougher here. Non-parallel chords of a circle can be extended to form secants that intersect in the exterior of a circle. The special relationship among secants segments excludes the chord. Okay, so we have two secants, and brings us to the theorem 10.16, secant segments theorem. All right, and what this theorem states is if two secants intersect in the exterior of a circle, then the product of the measures of one segment, secant segment, and its external secant segment is equal to the product of the measures of the other secant and its external secant segment. So this is a secant rule. Here's some notes already in the Smartboard lesson. So basically what we're going to say here is if you have the exterior part of the secant times the whole secant is equal to the exterior part of the secant times the whole piece of the secant. Okay, so when they say exterior parts, just mean these little parts here. Okay, like AD, or this little part here, AB. And when they say whole secant, it means the whole thing, all the way. Okay, likewise on both sides. So keep that in mind all the way. And you can see the example here, AC times AB. AC is the entire piece, or the whole secant piece, times AB is the small piece on the exterior part, is equal to the exterior part AD times the whole secant part AE. Okay, so here's the rule. Whole times external is equal to whole times external. So to remember this concept, the wording of theorem 10.16 can be simplified by saying that each side of the equation is the product of the whole secant and the external secant part of the secant. Okay, so you guessed it, we've got some questions or examples that are on 10.16. Let's get started here. Example 2. Find x, here it is, to the nearest tenth. Assume segments that appear to be tangent are tangent. All right, so we're going to start with this 8 first, this piece 8, and we're going to multiply it times 10. So we have the small piece on the exterior, 8. I'm going to multiply it times 8 plus 2, or the whole piece, okay? And that's going to equal x, the small piece, times x plus 11. X plus 11. Okay, so here we go. Let's do some solving for x. All right, 80 is equal to x squared plus 11x. All right. Now we're going to subtract 80 from the left and the right side. Subtract 80, subtract 80, and you have 0 is equal to x squared plus 11x minus 80. Okay, so we are looking for two numbers that when you multiply them together, you get negative 80. And then when you add them together, you get 11. Okay, so when you're factoring this out, that happens to be 16 and negative 5. 16 and negative 5. All right, so your two answers will be x plus 16 is equal to 0, or x minus 5 is equal to 0. So this answer does not make sense with regards to the example, negative 16. So we can just cross this off. But this one makes sense. X is equal to 5. And that's your answer. X is 5. Now, when you refresh your memory back on factoring, and some of the combinations there of 80 and 16 and 5 should stand out. Okay, let's move on to example 2B. All right, so you have yourself 8 and 6 and 2x, and it's noted here that this is also 8. So why don't you mark that down? Okay, so let's start with this side first. You have an 8 times 16 is equal to 6 times 6 plus 2x. So 8 times 16 is 128. 36, 6 times 6 is 36, plus 12x. Subtract 36 from both sides. And you end up with 128 minus 36, which is 92. And that is equal to 12x. Okay, so with dividing by 12 on both sides, you end up with an answer of 7.6, repeating. 7.6 with the 6 repeating. Letter C. All right, let's start with this side. So we have the 6 times the 6 plus 4x. And that is equal to the 6 times 9. Okay, got 9 by 6 plus the 3, okay, plus x. Okay, so you have the 6 is the external part. And then the whole part is 6 plus x plus 3, which is x plus 9, or 9 plus x. Okay, so make sure you note that. Okay, so 6 times 6 is 36. Then you're going to add that to 24x. And that's equal to 9 times 6 is 54 plus 6x. All right, we're going to solve for x here. And, you know, you've got variables on both sides. So you might do this a little differently, but I'm going to subtract 36 on this side and this side. And I'll have 24x is equal to 18 plus 6x. Okay, now you're almost home by subtracting 18 on this side and this side. Oh, take that back, pull that back. Subtract your 6x and subtract your 6x, and you end up with 18x is equal to 18. X is 1. So your 8x is equal to 1 for letter C here. X is equal to 1. Okay, we're going to wrap it up. Example 3, find RS, last one of this theorem. Then we'll come to our last theorem today. Find RS. Okay, RS is this little guy over here. Okay, so we're going to call that X. And we can see very clearly here that this is 2. And so we're going to take that 2 and we're going to multiply it by the addition of all the way. That's 14. Okay, so we're going to multiply by the 14. And that will equal X times X plus 3. That side is 3. All the way is X plus 3. Okay, 2 times 14 is 28. And that is equal to X squared plus 3X. Okay, now subtract your 28 from both sides. And you end up with 0. X squared plus 3X minus 28. Okay, so let's factor this. What two numbers, when you multiply them together, you get negative 28, but if you add them together, you get positive 3. X plus 7, X minus 3, minus 4. And your answer is X plus 7 is, X plus 7 is 0. And that answer is X is equal to negative 7. And that doesn't make sense. So you can cross that one out. So you're going over to this other factor, X minus 4 is equal to 0. And that's going to put that as X equals 4. And that would be your answer. X equals 4. So keep a lookout for that type of question coming up. All right, last theorem today is the tangent and secant. Let's go through that. So there's a different theorem that you use if you have a secant segment and a tangent segment. This is 10.17. Okay, so there's a special relationship here that says if a tangent and a secant intersect in the exterior of a circle, here it is, then the square of the measure of the tangent, okay, the square of the measure of the tangent, which in this case would just be JK, is equal to the product of the measures of the secant and its external secant segment. In other words, you're going to take this tangent measurement, JK, you're going to square it. Then you're going to take the external part of the secant, JL, and multiply it by the whole segment, JM. That brings you to the secant tangent rule. So the whole secant times the external part is equal to the tangent part squared. So you guessed it, we have some good examples to help you with this theorem. So here's a good note. I usually write the formula for this situation like in the example below. The tangent squared is equal to the external segment times the secant line. Okay, so lock in on this. DC squared is equal to DB times DA, the entire piece. So let's start with example 4. We have a few examples to finish up with today. And I have attached a worksheet you work on for the next couple days. Make sure that you note the numbers that I'm asking you to do, because there's not all of them on the worksheet. All right. Here's the first one. You've got the tangent 3.33. So I'll put that down first, and we're going to square that 3.33. 3.3, I should say. Then we're going to take the external part, which is 2.2, and we're going to multiply it by 2.2 plus x. 2.2 plus x. Okay, so let's move on. 3.3 squared is 10.89. Distributive property 2.2 times 2.2 is 4.84. Plus 2.2 times x. Okay, subtracting 4.84 from both sides of this equation. Brings you to 6.05. Divide by 2.2 both sides, and you end up with your x as 2.75. Tangent secant rule. All right, last page today, folks. Let's get through these and reach out to me if you have any questions. Letter B, you have the x. So we're going to take that and square it. And that will equal the 8 times the 8 plus 10, or 18. Okay, so x squared then is equal to 144. And take the square root, positive principal square root of 144, you get x is 12. Letter C, the tangent is 12. So we're going to square that. And that is equal to x times x plus 2. Now, x plus 2 is 2x plus 2. Okay, so keep that in mind. Now you got x, and then you're going to add the x plus 2. So you end up with 2x plus 2. Okay. Well, 12 squared is 144. And that is equal to x times 2x, which is 2x squared, plus 2x. Okay, now we're going to look to try to solve for x. I'm going to move the 144 over, and I will have 2x squared plus 2x. And if I subtract the 144 from both sides, I would have set up my factoring set it equal to 0. So I want to solve for the x by factoring. Okay, so I'm first going to see that I've got a factor of 2. So I can take out a 2, and that is 2x squared plus 1x minus 72 is equal to 0. Okay, so I'm factoring out 2 with the greatest common factor, or GCF there, of those 3 terms. Okay, so now you can see the answer kind of pop out at you with this negative 72, and that is 2 times x plus 9, x minus 8. Okay, 2 numbers that when you multiply them together, get you negative 72, that when you add them together, you get a positive 1. And your answers would be x equals 9, which we're not going, negative 9, which we're going to cancel that one out. Or your x minus 8 is equal to 0, and that would be equal to x is 8. X is 8. Okay, so keep a lookout for that type of questioning coming up. Last 2. Here we go. We have ourselves a figure here, and we've got a 15 on this side. We have a 5 on this side. So I can also say that this is 15. All right. And I've got an x here, and the x goes from, and that's your tangent piece. So I'm going to call it x squared. We're going to square that. So that will equal the 5, the exterior part. Now, let's focus on what the whole piece would be. You've got 15 plus another 15 is 30, plus 5 is 35. So x squared is equal to 5 times 35, which is 175. Now, if we're going to take the square root of both sides, you end up with x is equal to the square root of 175. Okay, so 175 is the square root of 25 times 7, and that is equal then to 5 times the square root of 7, or 13.23. 13.23. And the last one, section 9.8. By the way, this is the last section of this chapter, so that means that we'll have our quiz on this chapter next week. Will be letter E here. So let's take a look at this one. We got an 8. Okay, so we're going to take that. That's the tangent part, and we're going to square it. Then if you look closely, you've got a 6, and that's a diameter. And this is the radius of 6, so this is also 6. And you have this piece of x. So you end up with 6 plus 6, which is 12, plus x. So that would be the secant. X plus 12. And then that would be multiplied by the exterior part of x. All right, let's solve for x. 64 is equal to x squared plus 12x subtract 64 from both sides, you end up with 0 is equal to x squared plus 12x minus 64. And we're looking for the 2 factors that when you multiply them together, you get 64. When you add them together, you get this positive 12, and that factors out to be x plus 16 and x minus 4 is equal to 0. Okay, x plus 16 and x minus 4. Okay, to finish this up, you can see that we have one factor that's negative, and x then will equal 4. Okay, sorry for the long video, but I wanted to cover it in one segment. And I just want to make a note that you want to look closely at the two sheets that I've attached to the assignment and keep an eye on that I didn't assign all of them. So page 579, worksheet 1 through 9, page 580, 1 through 6 and 8. So special segments in a circle. And hopefully this was helpful for you and kind of a fun segment. And last segment of chapter 9. We're coming to the end of the class. Any questions, make sure you reach out to me, and keep up the good work. You keep impressing me every day. Thank you so much. Take care now. Bye-bye.